Hey everyone, welcome to an example on continuously compounded interest. So what happens here, the big difference between compound interest when you do it annually, semi-annually, okay, this means it's compounded continuously over and over again, okay? And the big difference here, what happens if we have our original problem, I forgot our principle here, if principal is equal to 1 plus r over n to the nt. What happens here is that this number here, as the more you compound it, okay, right here in parentheses, that growth factor, the more you compound something, okay, when n gets really large, the number of times you're compounding, this value in parentheses is getting much closer to the value e, and e to the first is approximately 2.71, and we'll just round there, okay? So this idea, if we compound continuously over and over again, okay, gives us a new formula for interest, which is A equals the principal times e to the RT. So our growth factor as n gets really large, okay, is going to get closer to the constant e. E to the first is 2.71. So this is what we're going to use. P is still the principal. That means the amount invested. Okay, R is your interest rate. Don't forget, in decimal form, and t is the number of years. So we're just going to go over a quick example of this, okay, compounded continuously. And how will you know, oh, how do I know it's compounded continuously? Okay, well, you look for it. It's going to say something like compounded continuously, not semi-annually, so you have to be given what you're compounding and how long, okay, or for how many times. So if you have $3,000 and you're going to deposit that into a savings account, and you're getting 3% interest a year, and it's compounded continuously, how much will you have after 7 years? So they've really given us everything we need to know. So I'm just going to go ahead and write my formula. A equals P times E to the R T. Okay, and this is all substitution now. You're going to have 3,000, okay, times E to the rate, which is 3%, 0.03 times 7. So there's the substitution, okay? And so when you plug that into the calculator, you get approximately $3,701.03, okay? That's what you're going to have in the account after 7 years. So that's just a quick example how to use compound interest when it's compounded continuously. If you guys have any questions or comments, let me know. We'll see you next time.